Welcome to the video. In this video, we are going to discuss the very important topic of the engineering graphics, that is the orthographic projection. It's a huge topic, and in this video, I will be giving an introduction about the orthographic projection. As far as the engineering graphics or the engineering drawing is considered, the orthographic projection is going to be a very important topic. Here, a look at the word projection. It is a very familiar word to us. We know about the film projectors. We have seen the projectors used for projecting PowerPoint presentations. What all those projectors are doing is projecting a film or an image to a wall or plane. That is the projection. Here the word projection is used because an object is being projected to a plane or to a set of planes. Here a 3D object is being projected to a set of planes. It is done so because usually the engineering drawings are done on a paper, which is obviously a two-dimensional plane. So to convert a 3D object into a two-dimensional drawing, we have to use the principles of orthographic projections. Now we look at the second word, which is orthographic. What is its meaning? So the projecting is not done to a single plane. Instead, it is done to several planes. And the condition is that all those planes are mutually perpendicular. So the orthographic projection can be defined as creating different views or multiple views of a 3D object onto different planes such that all those planes are mutually perpendicular. Even now, if some of you are not okay with the definition of orthographic projection, let's explain it with the example of the sphere as shown on the screen. Nowadays, many softwares are available to represent any 3D object in the 3D workspace, but to represent a sphere on the piece of paper so that an engineer can read it as a sphere on the first look itself is going to be a tedious task. By saying tedious, it is meant that a lot of shading is required. What we will be doing is drawing different views of this sphere from different angles onto the 2D drawing sheet. From these multi-view projections, an engineer should be able to identify the shape of the 3D object. So obviously, for a sphere, at any angle, the view are going to be circles. The next 3D object we are having is a cylinder. So we have to create the multi-view projections of this cylinder. That is how it is going to be look like on a paper from different angles. And for this purpose, what we need is an observer. Suppose he is the observer here. When he is looking at the cylinder from this angle, what he is going to be drawing on a paper is a rectangle. But with this rectangle, the engineering drawing of this cylinder is not complete. So we will draw another view of this cylinder from the above, which is going to be a circle for the observer. So by combining these two views, one engineer can deduce that it is a cylinder. Same explanation is valid for cone also. So from this angle, it look like a triangle for the observer, and from the top, it look like a circle. So combining these two views, one can deduce that it is a cone. It seems to be very easy when the object is a simple one, but the process of mental mapping becomes more complicated when the complexity of the object also becomes higher. So let's take an example from our real life, which we are already familiar with. The first thing coming to your mind by seeing this diagram will be a similar diagram of your own home. Many of us maybe don't need an explanation of what this drawing is going to tell about the house. For those who don't understand this kind of drawing, let me explain this from the perspective of engineering drawing. It's a multi-view projection of a house, and you can identify two views here. That is how it is going to be look like from the top, the roof removed, and also how it is going to be looking like from the front when you are standing in front of the house. You just imagine 10 to 20 years back from now, this was the only method by which one can express how will be its dream house going to be look like when it is completely built. But now there are plenty of softwares available by which you can make 3D walk around, even with the painting done and furnitures at their proper space. You will be able to visualize in an efficient manner. The view from the front of the house is known as the elevation of the house, and the view from the top of the house is known as Yes, you are very well familiar with that term. It is known as the plan of the house. So it is the example which we are very familiar in our real life, and in future you will be dealing with more of these kind of elevations and plan of more complex mechanical objects. Let's return to our 3D cone again. Previously, when I discussed about the film projection, it is understood that for the projecting the film, we need a wall or a plane to which the film to be projected. So similarly, for a 3D object to project its different views, we need 2 or 3 or 4 different types of planes to project its two-dimensional views. So here, minimum we need 2 planes, that is the HP and VP, to project effectively its two-dimensional views. HP, that is the horizontal plane, VP, that is the vertical plane, are two mutually perpendicular planes. These HP and VP can have different orientations. Suppose here it is VP and this is HP. Here this is HP, this is VP. Here this is HP and this is VP. So commonly the horizontal plane HP and the vertical plane VP, they are known as principal planes or reference planes. So minimum we will draw 2 views of an object, that is one which is projected to the vertical plane and the other which is projected to the horizontal plane. As I said, there are different orientations for HP and VP. It is commonly known as the quadrants. So it is known as the first quadrant, this is known as the second quadrant, this is the third quadrant, and it is the fourth quadrant. You may have already noticed that the quadrant names are given in an anti-clockwise system. That is 1, 2, 3, 4. The quadrant names are in an anti-clockwise direction. The cone is now placed in the first quadrant, and if we now project the 3D cone into vertical plane and horizontal plane, the projection thus obtained will be known as the first angle projection. Similarly, we can move to the second quadrant and we can make a second angle projection. Then we can also project in the third quadrant, and also we can do it in the fourth quadrant. But the point you have to remember is that usually we will use only the first quadrant and third quadrant for the projections, and we do not usually use the second quadrant and fourth quadrant for making projections. Why we are not using the second and fourth quadrant for projection, that you will get by the end of this video. In any quadrant, after placing the object, we are not drawing only one view but multiple views. That is, it is known as a multi-view projections. There are different names for different views in a multi-view projection, like front view, side view, top view, etc. And the name of these views are derived with reference to the observer who is viewing the object. The observer is looking to the object from here, so the view he is getting of the object, that view is known as the front view. So it is applicable for any quadrant. For any quadrant, the position of the observer is not changing. He is viewing from this position only, and the view he is getting is known as the front view. Now the doubt that many will be having in their mind will be that if the object is in the third quadrant, how the observer is going to see that. Here we have to apply some imagination, like all the HP and VP are transparent. In that case, the observer will not be having any difficulty to see the object even if it is in the third quadrant. Front view is clear for us now. Now we will discuss some other views. If we are moving to the left of the observer, that is, observer is not moving, we are moving to the left side of the observer, and the view we are getting of the object, that is known as the left side view. So keep in mind that now you can see 2 objects and 2 quadrants, but in reality we will be only dealing with one object in a single quadrant. For the explanation purpose only, 2 objects are shown, one in the first quadrant and the other in the third quadrant. Now we will shift to the right side of the observer, and the view we are getting is known as the right side view. Object may be in any quadrant, but the view that we are getting from this side, that is known as the right side view of the object. Now we move above the observer, that is we are looking from the top of the object, and the view that we are getting is known as the top view. The object may be in any quadrant, and like I said earlier, the planes may be considered as transparent so that we can get a top view when the object is in the third quadrant. Similarly, we can create a bottom view also. That is a view of the object that we will be getting when looking from the downside, and that view is known as the bottom view. Here I am marking the names of all the views that we have already discussed. So you can see this is the front view, this is the top view, this is the right side view, and left side view, bottom view, and one more view is there, that is the rear view. The view of the object that we will be getting by looking from behind of the object, as we call the rear view mirror for a vehicle. Now there is a basic question, that is, even we are getting different views on different mutually perpendicular orthographic planes like top view, side view, front view, etc. But to convert that into a 2D plane, that is a two-dimensional drawing sheet, we need some further assistance. So to explain that, I am here just showing an animation so that you can get a better understanding of this conversion. The object may be in the first quadrant or in the third quadrant, and we will be having two views, one on the horizontal plane and the other on the vertical plane. And next step, what we have to do is that we have to rotate this horizontal plane into 90 degree in the clockwise direction, like I am showing now. And by this, the view in the horizontal plane get superimposed onto the VP, and here we will get the front view and here we will get the top view. And on the other side, here we will get the top view and here we will get the front view. After getting this, we will copy as such these views into the 2D drawing sheet. So we will be getting two views, that is the front view and the top view. So minimum there will be two views for the multi-view projection for an object in first quadrant or in the third quadrant. Now we can discuss on the point that I made previously, that usually for a 3D object we are not making any projection in the second quadrant or in the fourth quadrant. The rule for rotating HP is same in any quadrant. Even if it is in the second quadrant or in the fourth quadrant, the HP should be rotated in the same manner. So you just imagine if it is in the second quadrant and there are two views in the HP and VP, forget about the names. Then if we rotate that HP into the clockwise direction like I discussed earlier, in that case the two views will merge each other. So what we can deduce from that combined view of an object? We can deduce nothing from that. You just imagine that you have got a plan and elevation of your house and you just merge those together. And what we can deduce from that plan and elevation? Nothing we can deduce. So same happens in the second quadrant and in the fourth quadrant. This is the reason why we are not using the second angle projection and fourth angle projection. As per the BIS, that is the Bureau of Indian Standards, we are using the first angle projection, and to represent that we will be using specific symbols in the drawing sheet which represents that the projections we are making is on the first quadrant, that is the first angle projection. There will be more videos on first angle and third angle projections, the symbols used and the difference between them. Please watch that also. Just take the example of a house. So there is the elevation and plan. The top one is known as the elevation and the bottom one is known as the plan of the house. So in graphics, usually the elevation part is referred as the front view of the object or front view of the house. So front view is also known as the elevation. And similarly, the top view, which we usually refer in graphics as the top view, is also known as the plan. So in question paper also, if it is asked about the elevation and the plan, it is referring to the front view and the top view of the object. Even if I said that we will be using either first angle projection or third angle projection for a 3D object, in the textbook you can see there are questions relating to second quadrant or fourth quadrant for projection of points and projection of lines, and those are given so that you can have a better understanding of this multi-view projection in different quadrants, and also you should be very familiar with the concept of rotation of that HP. And in reality, for a 3D object, you will be only referring with either first quadrant or the third quadrant. To check your understanding from all these discussions, I am presenting here some problems, that is presenting some front views and top views from which you just imagine what will be the 3D object will be looking like. So first one, you can see front view is a triangle and top view is a rectangle. And there is a second one, front view is the triangle and top view is a circle. And the third one, the front view is a rectangle and the top view is a square. And the fourth one, that is the front view is a rectangle and the top view is a circle. By all these discussions, you should be more confident by the concept that by just looking at two drawings or two views of an object, you are able to identify its three-dimensional shape. That is, from the front view and top view, you are able to identify what that object will be looking like in a 3D space. And that is the concept of orthographic projections. This is enough for this video, and thank you for watching.